This is Polymel, Physics 350, Homework 5, Problem 1. We want to find the general solution of Laplace's equation in spherical coordinates, assuming that R is dependent, or V is dependent on R, the potential. We give an example of a charge distribution that this equation may apply to. So Laplace's equation in spherical coordinates is this right here, this long thing. If V only depends on R, the terms with theta and phi end up dropping out as 0, and we're left with Laplace's equation is this, where we're only dependent on R. Laplace's equation is equal to 0, so we set this up here equal to 0. We multiply this r squared over to the other side, and then we start taking integrals. We get, with the first integral, we get a constant. We have r squared is the derivative of the potential with respect to r. We integrate again. We'll move r squared over and integrate again. And we get another constant is equal to the potential. If we wanted to, or a charge distribution that this would apply to is a conductive sphere. The potential is dependent only on r and not theta or phi. So the distance away from the origin is the only factor in all directions of the uniform sphere. If we wanted to know these constants, we would apply our boundary conditions. The potential at infinity is 0, so we would set this r is infinity, and and we find the k constant is 0. From chapter 2, we know that the potential is of the point charge is q over 4 pi epsilon naught r, and our equation where we have our constant over our our distance away, we find the potential is negative c over r, so c must equal q over 4 pi epsilon naught.